Welcome to our Zoom presentation of Mobile Mobility Hub Network. You will see our process using design thinking and Scrum creative ideas to our final solution. But first, here are the team, Mobility Hubbers. My name is Ann-Sofie Soleby Eriksson. I'm from Sweden and up in the left corner.
And my name is Michael Nettesheim. I'm from California.
My name is Alejandra Plata. I'm from Colombia.
I am Veera and I am from Finland.
I'm Laura and I'm from Germany.
Our challenge from Region Stockholm Public Transport Authority, known as SL, was to create a functional solution containing services that attract people to travel in a more sustainable way. For our challenge givers, that meant developing a physical mobility hub that would allow for the testing of services mixes. Their hope was to influence behavior, to convince Stockholmers in more suburban areas to make more sustainable transport choices by adding popular service to public transit. At the start, we were really constrained by our challenge givers' focus on physical hub. So we felt boxed in by the idea of a mobility hub. So we instead focus on the underlying goal, influence behavior and attract users to public transit. This leads us to a reinterpretation and rephrasing of the challenge, which we based in insights from our empathy phase. The reinterpretation was, how might we create an attractive solution that can improve the well-being of residents and provide the sense of autonomy, comfort, safety, and ease of access that privately owned cars provide.
This reinterpretation of our challenge led us to develop concepts that were aimed at trying to solve an underlying problem: lack of engagement with public transit and low use of other forms of sustainable transport. We developed concepts focused on influencing behavior part of the challenge, and not as much on creating a mobility hub. The 5 concepts you can see in this slide are the ones we shared with you during the midterm presentation. When we discussed these concepts with our challenge givers, they were supportive, but ultimately made clear that they were more interested in our user-centered work, contributing to the mobility hub solution path they had already set out on, and not as much in us creating new concepts. That is, they wanted us to use our insights to inform the physical design of a mobility hub through which they could test the impact of service provision on the transport-related behavior of users. We condensed a summary of their feedback into the 5 points you see here. Based on this feedback, we redefined our challenge yet again. Our new redefinition was, how might we create a physical hub design that would be attractive to users in rural/suburban areas and is responsive to their needs, while also ensuring enough spatial flexibility for SL to test various services and supplemental features.
After the redefinition of the challenge, it became clear to us that every design element that we wanted to include in physical hub would have to be rooted in users' feedback. So then we wanted to reconnect with our users, and we did that in 3 steps. The first one was to create user journey maps of our 3 personas that we created earlier on in this process. And personas are, as Dark also mentioned in the last presentation, fictional characters that are created to represent a certain user type. On the slide, you can see the different journey maps that we created for our personas. And we highlighted the pain points that our users might encounter during their daily journeys when they rely on public transport. And based on these pain points, we identified opportunities for the hub to solve these challenges. The main takeaway from this customer journey mapping process was that our users encountered the most issues during the first and the last parts of their journeys. The second step was then, after the journey mapping, to re-immerse ourselves in the neighborhoods that our challenge givers listed as potential locations for the future hub. And we did that because we wanted to observe in the field, so in real life, these opportunities that we earlier identified in the journey maps. And while we were there, while we were visiting Upplands Väsby or similar locations, we realized how much the location of the hub would ultimately influence how high the user engagement and usefulness for the users in these areas would be. We also think that it should be the users that decide about the appearance and the character of the hub in all these specific locations. So finally, as the third step in reconnecting with our users, we launched a user preference survey because we wanted to understand the service preferences of our users a little bit better, so that we could then, based on that, make recommendations about which services should actually be included in the hub. In the survey, we presented 7 different services, and this diagram shows you how well these services were received amongst the 111 people who filled out our survey. The results suggest that on average, none of the services would significantly increase the level of engagement with public transport on its own. But the data, when it's sliced by location or other variables, shows that services like, for example, parcel pickup or comfortable seating can be seen to be more influential among certain user groups. And overall, it can be said that the services were relatively well received, and that indicates that implementing or at least testing all of these services is worth it.
So after reconnecting with the users, we wanted to address the challenge directly by ideating potential physical elements, but without losing sight of the important insights that we actually already gathered in the first half of our process. So we started the ideation brainstorming by answering the 4 how might we questions you can see here, and then grouped the ideas and we voted on which to move forward with. We ended up with a list of potential physical elements or characteristics, you could say, that could be included in a mobility hub in order for it to have the desired functionality and impact. We then verified some of those characteristics by doing some rough prototyping using various materials such as Legos, whiteboard, or 3D software. And after this rough prototyping, we were ready to make 4 end product models, which we are going to present next. The first 2 models, the screw hub and the box hub, are similar in concept, but different in form. The core component of each are small modules that contain different services which you can add or change. Since densely populated suburban private housing areas are lacking in space, this hub could fit in a parking spot in its tiniest form, but it can also be expanded to contain a mini supermarket or just adding more modules. You can see how these modules could be combined in this slide. For example, a 2-module hub could contain an e-scooter module and a parcel pickup station like Instabox. And another could offer both of those and maybe a grocery store module. However, the most basic version of this hub consists only 1 module, like mobility-based electric scooter module. So the first form that these modular models could take is the screw hub, which is inspired by the form of a screw with the roof like canopy and the body containing modules. Here you can actually see an example of what this hub could look like in its tiniest form and how it could be expanded into this larger format. This model would always offer micro-mobility services like scooters and bikes under this roof, but its body is the one that is versatile as responsive to service needs and space limitations. Then we have the box hub that is made of modules as well, but the hub's structures is not made by a central body and a canopy, but by the actual modules or boxes. And this was more like inspired by Lego or containers, in which you have a basic pieces you can add on to create smaller or bigger structures with more or less services.
While the modular screw and box models provide a high level of flexibility and simple service provision at low cost, our third and fourth models, which we'll talk about now, the space hubs, would be more building-like and would be focused on the provision of space rather than just services. The two versions of our space hub, which we will describe in the next two slides, or in the next slide, address user demands for two types of additional spaces within the transportation system. The first kind of space needed, primarily in suburban neighborhoods that are far from their more urban centrums, is a community space. To fulfill this need, we've modeled a suburban community space hub, seen on the left of our slide, which would be focused on providing the following to its users. First and last mile transportation services to get residents from main station closer to their homes, a community-oriented space in which to gather, relax, plan trips, or access services. And last, goods and services that fill provision gaps in suburban communities.
The second space need is for an inviting waiting space in close proximity to the main station of a suburb that could also meet the needs of further transportation. Therefore, second model, the station improver space hub, which you can see on the right side of the slides, would provide the two following things to the users. First of all, a cozy space in which people could sit and wait for the next bus or the next train. And secondly, a starting point for further travel where the users could easily access sustainable transport options, such as e-bikes or e-scooters, rental bikes, and things like that. And as you can see, both of these space needs are very location specific. So a space hub would need to adapt and to respond to changes in needs based on each specific location. In addition to that, in order for these space hubs to stay mobile and transportable, despite their more building-like structure, the space hubs could be built on simple platforms with section walls and section roofing to ease deconstruction and then transportation.
And so while modeling, we were thinking about our insights from our customer journey maps and the time and uplands VASB regarding the importance of the hub location. So we began sketching a geographic version of a customer journey on a whiteboard. And by drawing this map, we realized about the strategic importance of location, how the different services of the hub would depend on the location. So for instance, if it was on a street in the middle of a suburban area, the hub should instead serve as an intra-local transport solution or a way to get to main public transportation services. But in order to work like this, the users should be able to drop off the e-scooters or bikes in every hub so they can hop onto their buses or trains. Also, if it was in a more isolated suburban area, a convenience store would be actually a useful service, as users wouldn't need to take their car to buy groceries. But if the hub was located in a place near a station or a bus route, then including coziness and comfortable chairs would make sense, as that would serve as a waiting area. So by putting the customer journey in a map and taking into account the different needs of the population would have, depending on the specific area where they live, we recognize that one mobility hub would never serve all members of a community and probably wouldn't have a real behavior changing potential. So in the end, we realized that what our users needed was not just one hub, but many. They would actually need a network of hubs.
So when we realized that our 4 different models could not cover users' needs in different parts of the suburbs by themselves, but that a combination of all of them to one big hub network could solve this issue. Our mobility hub network is like a spider web made of different hubs all over suburban area, connected to each other with microtransport options. Each hub would offer specific combinations of services adapted to local needs, from different micromobility options to cozy seating and parcel pickup. All the different hubs we have presented could come together to form this hub in a way that meets the needs of residents of each area as well as space requirements. This illustrated map of a suburban area in this slide shows how one of our modular hub models together with the space hub could come together to form a network. Hubs could be placed strategically so that more services are offered at the certain high traffic locations, but at least some access to mobility solutions are available to all areas. The flexibility and modularity of our models serving as the base of this network is hugely beneficial because it allows the adjustment and optimization of the system by simply shifting or adding modules according to demand. At the same time, all the hubs would offer parking or charging spots for the mobility services like e-scooters, borrowed from other hubs in this spiderweb system. And this would prevent that quite irritating improper parking that we can see at the moment in Stockholm and other cities, and ensure that electric transport services remain charged. The hub network would allow residents of suburbs to truly rely on sustainable transport options instead of their cars, and the opportunities that a network would provide to build engagement is exciting.
Directly focus on assessing of our hub network to the reality. We did a SWOT analysis and listed the network hub's strengths, weaknesses, opportunities, and threats. I want to highlight some of the most exciting results from that analysis. One of the coolest opportunity and possibility that SL could adapt services and features regularly depending on users' needs by shifting models around or develop new ones. The shifting node-based nature of the network could allow it to be used as a site for innovation and the testing of new transportation solution. The hub is remarkable, flexible at a low cost since it's based on inexpensive model use. This will allow to meet specific services needs without large-scale infrastructure changes. From a user's perspective, the hub network's strength is that it would offer a more sustainable form of cheap transportation for local suburban travel and main station access. From a society point of view, the hub network could, 1, contribute to the sustainable goals, 2, strengthen local communities by building collaboration with local businesses, and 3, increase communication with municipalities through mobility hubs that offer community space. All of these things contribute to a greater potential of the network hub as a concept. And over to conclusions.
This whole process has been an incredibly interesting and exciting one for our team. Throughout the project, the people we met, the personas we imagined, and the design thinking methods we used all led us to think more deeply and more creatively about our challenge. The most important and impactful insight we gained during our process was that ultimately, one mobility hub will not be able to solve the issues faced in the Stockholm's suburban areas on its own. An entire hub network, on the other hand, could serve whole communities and incorporate a huge variety of services, building engagement with the network and reliance on it. We're genuinely excited about the hub network's potential to provide sustainable transport, user autonomy, to connect communities, and to serve as an infrastructure for further innovation. In this concept, we see an exciting example of what Stockholm of the future could look like, and we hope you do too. Thank you.